Hello, my name is Frederick. I'm the CEO and founder of Sustainly, and for this tutorial series, we're going to take a look on how to get started with Sustainly and to get started with your first lifecycle assessment. First of all, if you start here and you don't have an account, all you do is you can give the model a prompt. In this case, we're going to take a look on a polypropylene cup, and I'm going to send it off, and it will ask me to create a user. I'm going to put in my information here. I'm going to use a new email address that I haven't used before and click continue. And now I will receive a code, and I'm going to cut to when I have received that code. Here we are. And now that I have a user, I'm going to click send again. The system will automatically set up your organization and start creating your LCA. So you can see that the AI panel opens up here and starts generating my LCA. So what happens is that it will start generating the lifecycle stages. So those stages are depending on the type of product you're analyzing, but typically it will be stages like raw materials, manufacturing, the use phase, the end of life phase. It can differ depending on the input that you give it, how broad the scope is, and of course you can be very specific in your instructions if there are certain stages that you want to include. It will also generate the nodes, and that is both nodes that are representing the raw materials, transportation, and the waste stages. And finally, it will then find relevant background data set and add reasonable amounts. So the first thing we want to do is to kind of sanity check the model now that it's done. So if we start with the raw materials, we can see that we have a polypropylene input node. We can see that there's more than the amount we wanted, 49 grams, but it's actually inputted 54. So let's check out what the reasoning is. Okay, so it's 49 grams times 1.1. And the reason is that it is adding a waste amount in the next phase with manufacturing. So the model is actually assuming that there will be waste in this process. So here we have a waste amount corresponding to 10% of the 49 grams. Then there's some electricity here. It's using a grid mix. That's pretty standard. Of course, if you have better information on the specific product you're analyzing, you can use that. And then there's an injection molding cone. Injection molding process. And the reason that it's chosen, the AI has chosen plastic bobbin cone here, is that the process of modeling the plastic bobbin is quite similar to modeling the cup. But let's see if we can find what that is better. If we search for injection molding, there is actually a data set here specifically for polypropylene. So let's use that instead. We can maintain the same amount. That looks correct. And then there's a washing process where we have a washing on 60 degrees, and we have some wastewater here. And the wastewater node we can see is not correct. It's using some recycling of post-industrial polypropylene waste, and it's very likely that the wastewater is actually modeled in the washing. So I'm going to delete the irrelevant node here, and then we can see in the end, it has also, for whatever reason, created both a landfill waste and a landfill. And what we do is we take the landfill node. This looks correct. This one down here, it's chosen some end of life for water fountains, PP without BFR. We'd have to read the details of this dataset to understand if this can act as a proxy, but using the more general landfill node up here is probably fine. So I'm going to delete this. And now we actually have a fairly sound model that is representing the life cycle for this polypropylene cup. And so we're going to stop here. And then in the next video, we're going to take a look at how we can replace the proxy that is currently used in the washing state with a more detailed breakdown of the dishwashing cycles. So follow along in the next video.